On the 2nd of August 2019, at a test track hidden deep within German woodlands, the Yeti engineers and their test driver, Andy Wallace, set out to break a production land speed record and shattered it by almost 50 kilometers an hour. A record predicted to take a decade was just done in 2 years, and yet it disappeared from the headlines in less than a week. For 100 years, automotive focus has landed on one single question: which manufacturer can break the production car land speed record? And one after another, many tried. Manufacturers from aeroactive devices conjured deep within Group C Le Mans cars to the McLaren F1, reaching an astonishing 250 miles per hour at a private test track in Erlstein, Germany. In 2005, the Bugatti set to break the record and reach 250 miles per hour. The Koenigsegg Agera RS later raised it to 278. And finally, the 300 mile per hour barrier fell to the Bugatti Chiron Supersport 300 Plus. After that, interest stagnated. Manufacturers realized that consumers had lost interest in the topic. Bugatti publicly withdrew from the competition, saying that they would rather focus on other areas. The record had transitioned into a meaningless number, achievable only with single-use Michelin tires, specifically designed for Chiron's record run. Oh. 450 kilometers away, at the world-renowned Nürburgring Nordschleife, a new benchmark was already forming. The circuit, with its extraordinary length at 154 corners, had become the new battleground for manufacturers to prove who truly built the world's fastest car. Look at the record sheets. Two patterns leap out. First, every record has been set in the past 15 years. Second, the frontier of the list has been dominated by electric vehicles and hybrid vehicles, a testament to the dizzying innovation in electric powertrain technology. The current production car is held by a hybrid Mercedes-AMG 1, set by Mauro Engel in September 2024. The fastest fully electric car is the Rimac Nevera, designed in Croatia by Adriano Modri. So what really changed? 3 things, and all of them happened in the corner. The first is torque vectoring. For 100 years, a car had one single power through a mechanical drivetrain to its wheels. The Rimac Nevera has 4 electric motors, one per each wheel, and adjusts the torque, each of them roughly 100 times per second. There's 400 decisions a second from the powertrain alone. It allows cars to do things in a corner that internal combustion simply cannot. The second is active aerodynamics. Cars used to have a fixed shape, chosen once in the wind tunnel and lived with forever. Now wings tilt, flap open, and under trays adjust in real time. The McLaren Senna generates 800 kilograms downforce at 250 kilometers an hour, almost its own weight, pressed into the road by air alone, and then flattens its rear wing on the straights to reduce the drag. The third is active aero suspension. Magnetohelical dampers, oil filled with iron particles that align in a magnetic field, adjust the stiffness 1,000 times every second per wheel. There's 4,000 decisions each second. Keeping the car flat through corners you can barely even feel is happening. Add it all up, and a modern performance electric vehicle is making between 5,000 and 10,000 micromechanical decisions every single second you are driving it. That is not autonomous driving. The driver is still in charge, but the driver's commands are being translated through thousands of simultaneous, perfectly timed physical acts. 100 years ago, driving a car was playing a key on a piano. Now it is more like conducting an orchestra. And this is where the story stops becoming about cars. We measure the greatness of an engineer by how much force they could unleash. The bigger the engine, the bolder the bridge, the taller the tower, the more we celebrated. The hero of the industrial age was the engineer who could move more weight, more power, more speed, and more material. The car, for most of its history, was the most visible monument of this ambition. But the world we are building is now finer, smarter, and more attentive. The hard problem is no longer making the engine bigger, the chassis stiffer. It is making thousands of tiny systems coordinate in real time, listening to a wheel, a sensor, a damper, choreographing the response faster than a human can even blink. The challenge is not how much can we do it anymore, it's how precisely can we do it. And the same pattern is appearing in every field that matters. In medicine, prosthetic limbs are now reading nerve signals and responding in milliseconds a bionic hand adjusting its grip 100 times a second to match a fragile egg or a coffee cup. In aerospace, the next generation of aircraft is being designed with micro flaps and flow control devices that argue with the air over the wing in real time. In construction, the tallest buildings in the world are using active dampeners and multi-ton pendulums that take earthquakes and wind and counteract them, keeping skyscrapers still in storms that would have otherwise toppled the buildings of the past. In each case, the engineering frontier has moved from how much can we do to how much can we do it, how well can we do it. From force to finesse, from power to attention, and what does this mean for the rest of us? It means the world we're living in is becoming more responsive. The objects around us are starting to listen. Your car listens to the road, your pacemaker listens to your heart, and from better or worse, your phone listens to your voice. The future is not louder, it is quieter, and more careful, and more attuned. But going back to cars, the Bugatti Chiron Supersport 300 Plus broke the world land speed record for the fastest car in the world. I bet most of you would have never even heard of it. The fastest car in automotive history disappeared from the headlines in less than a week. But the cars rewriting what greatness means. The Nevera, the AMG 1. Those are the cars thinking 1,000 times a second underneath the driver's hands. The cars our generation, 100 years from now, will remember. Because they are not just faster. They are the first machines that listen. And once the machine listens, everything changes. The future of engineering is not coming. It is already here. It is in the corner. Thank you.